our next module, that would be our Android startup process. So how the Android application works in the very first boot menu. So when we are booting the applications. So over here, some you can say I have given some questions. We think about the Android boot sequence, how the boot sequence works over here. What is Zygote? What is INC? Init.rc? What is the difference between the Linux kernel and Android Linux kernel? So we're going to learn about all these things one by one in our upcoming sessions. For example, if you see on the screen, this is a process how a mobile application boot manager works like. So the first thing is your boot ROM, then the bootloader, then we have kernel. Kernel are divided into three parts, like your daemon, zygote, and runtime. And a kernel is also get initialized and then zygote. Then zygote, we have Delvic machine, which is our fifth level. Delvic machine, which is virtualization, and the sixth one we have system services and managers. And through that, we can simply get the runtime and the service managers over here to get the activities over there. So in this sixth level, we're going to learn about all these things one by one in this module. So if you see down, we have the very first thing, the first step, it's all about our power on, the system startup. Power on the system startup, it's all about to execute and initialize the power setup. When we press the power button, the boot ROM code start executing from the predefined location, whereas the hardwired is in ROM. It loaded the boot loader in the RAM and start the execution part. So they are comparatively independent. When you have the code is written over here, hardwired, it will load the bootloader, which has the options to execute the function over here. So जैसे कि अगर बात करें यहाँ पे boot loader की बात हुई है, जैसे कि अगर आप देखो, this boot loader is a small program which runs before Android. This is not a part of your Android operating system. See? The bootloader is a place where manufacturer put their locks and restrictions. The bootloader executes in two stages. In the first stage, it detects the kernel external RAM and load a program which helps in second stage. In second stage, the bootloader set up the network memory, etc., which requires to run kernel. The bootloader is able to provide configuration parameter or input the kernel for the specific purpose. So as we know that the bootloader has divided into two parts, which has over here given after the bootloader we can see kernel. Kernel are divided into two parts, which is your daemon and runtime. But in the bootloader they have given two stages, where it's from external RAM to load the files, and they have the memory layer of the network part for configuration parameter values. So you can see the bootloader can be found on, you can see the Android source, the bootloader legacy.file. So this is a proper architecture in your mobile Android device. You can see what are the things you can find. There are legacy loaders contains 2.5, which is your init.c or main.c. Initialization. Initialize the stack memory, where the memory execution works. 0 to VSS segments and call main function. Call main function, the application part. So main.c. So main.c initialize hardware, which is your clock, board, your keyboard, your console, and create Linux tags. So there are two parts. Remember one thing: initialize and main.c, which compare with the two different legacy parts. One is for your stack memory, which is used for execution part, and second one is all about your hardware initialization, which is your keyboard, mouse, and console. Console where we can simply execute our commands. The third one you can see is your kernel. Kernel plays an important role in our upcoming session. Why? The Android kernel start in the similar way of Linux kernel. As the kernel launches, it starts with the setup caches, protected memory, scheduling, and slow drivers. When the kernel finishes the setup, it looks for initialize in the system files. The initialize with the application is running in the stack memory or the hardware memory. So you can see they have given what is the difference between a Linux and an Android kernel. They have given some categories over here. You can see binder, which is your inter-processors communication with the mechanism or the Android to communicate. Ashman stands for Android shared memory. Is a shared memory allocator similar to POX, which is basically used for base similar application part. Android shared memory is an application type of memory part. PAM, which is your process memory locator. Loggers, you can read about all these things. Wakers, wake lock. This is used for power management files. You can see OM handling. It kills the process of available memory becomes low. Alarm manager. It uses a special time for kernel to wake up. RAM console. It allows to save kernel print message to buffer RAM. And USB gadget driver is ADB. So there are some files they have given over here one by one. But the most important thing that you should learn about the steps. Step 3 is all about your initialized process. As per the diagram over here. Step 4, which is your initialization process. If we talk about the initialization process, we already talk about it all about the processes which is running in the back end of the server. For example, I have my Linux server system. So we have my Linux over here. So what are the applications are running in the back end process? I can check it by easily. For example, what we can do, we can try PS, which is a process, AUX. So very first thing you can see, all the applications are running in the specific way and we can maintain over here. For example, if you go up, you will see the first application will be run as initialization part. It will run in the top of the binary. Same just like you over here, init is a very first process. We can say it is a root process or grandfather of all process. The initialized process has two responsibilities. Mount, which is basically your directories, like your system directories, your dev directories, and your processor directories. Runtime initialized scripts. The initialized process can be found in the init, which is your Android source system core init file. Or if you look for init.rc file, can be found at this specific directory. Initialization is you will have a process or a script over here which is written in the specific time. Or you can see Android have a specific format and rules for initialization RC files. For more information, you can read about this one over here. You can write psgrep init. Initialization. You can see all the program login files. Let's run our Genymotion first of all for better understanding. So over here, let's run Genymotion. And over here for penetration testing, I'm going to use my Kali Linux. But first of all, let's check the IP address of this device. Okay, so we are going to go to the settings and the Wi-Fi, and the IP address is 106. Okay, so let's go over here back, and I'm going to use clear tag ADB. I'm going to use ADB over here for connection. I'm going to use IP address 106. We're going to use ADB shell, or we can use ADB. That's PSAUX. Okay, this will not work, so we're gonna write ADB shell. I thought it will work, so let's AUX, and we're gonna use grep. Let's try with the PS first of all. So over here, there's no application was running. Let's try to execute some commands over here in the backend. For example, let's do diva. Let's run some browsers. Let's try some emails. Now let's try this. Okay, so PS AUX grep root. Okay, no application is running over there. PS AUX. Okay, so let's use PS AUX grep initiate. None of the application is running. Okay, sorry. I thought it will run AUX. So the AUX was not running, so ps grep init. You can see the base machine which will run over there in the very first step, which is your first process ID. And you can try to see over here also. Initialization. Process file. So over here we can use grep init, then we can run over here to identify the application is running over there or not. And you can see that there were many applications we have run, but let's close those things. So in the screen you can see we can simply get all the initialization process in our system because it contains the systemation files, the development file, and the processor files on the server side. So there are many other things that we can proceed with. So over here you can see the next stage, which is our Zygote and Delve. So Zygote is our in 5th stage. So let's read about this one. What is Zygote means over here? In the Java, we know that the separate virtual machine instance we pop up in memory for separate per app. But in the case of Android, the VM should be run as quick as possible for the application. Okay. But what happens if the several application may launch several intents of Delve machines? It will consume the immense amount of memory. So it's a logic thing. If we are running multiple applications, so it will take lots of memory on the device side. But we can see to overcome this problem, Android OS system called Zygote. The Zygote enables code shading across the dynamic machine, achieving a lower memory footprint and minimal startup time. Okay, Zygote is basically used to consume a lower memory footprint part, or consuming the lower memory of the dynamic machine. So it can be used for faster process. Zygote is a virtual machine process that starts at system boot. And Zygote preloads and initializes the code library classes. You can see there are loading process of Zygote. For example, load the Zygote initialized class file. You can get the files from here. Framework, base code, java.com, android zygote.java. You can see the registry files. It is a register server socket or Zygote command connection. Preload classes. It's a simple text file that contains a list of classes that can be need to preload. And you can find the file at the Android framework base. And you can see the resources. Everything that will be included in the Android R will be loaded with the method part. So you can see the process of Zygote. You can run over here to check the application which is running over there. You can see the boot animation part. So what we can do, let's see if the Zygote is running or not. Zygote. Yeah, I can see the Zygote is running with a full buffer memory. You can see FFF, which is broadcasting. So some of the basic kernel steps we have to know about the system part. So Zygote is all about running the base memory with the virtualization process. So we have the 6th one, which is your server memory. System services. System services, what are the applications that are running in the processor side? After the above steps are completed, Zygote launches the system services. The Zygote forks new process to launch every application. System services means the default applications. For example, you can see your activity manager, which contains all the logs and lists. Telephone registry, package manager, manager services, root process manager, content provider, services manager. All the things is given default. These are the default application which is running when you are simply executing your cell phone or other device. Starting status and bar services, hardware services, next state services, connectivity services, notification services. You can see all the things one by one. You can see we finally complete the booting process system services as a forthcoming memory. Need to analyze the boot memory. You can use ADB to get the booting process event from the logcat. ADB logcat -d event and grep boot. You can use this command to identify the boot memory layout. It's all about to analyze the logs. Logcat is all about to fetch like your sniffing method. So we can simply check the boot menu over here. For example, see over here. So I'm going to use the ADB logcat. So ADB logcat. If you use logcat over here, you will see all the logs which is predefined over here one by one. These are system logs, IP table, CVC, emulated camera, Delvic VM. There's a lots of other things, resources. So what I'm gonna do hyphen blockhead, hyphen D, hyphen B. We're gonna use some events, and I'm gonna use grep command to check the boot. So you can see all the applications which are running over there. If you doesn't know the function adb blockcat, use hyphen help. I use hyphen D to dump the logs and then exit. I used hyphen B to check the buffer memory. So you can see over here hyphen, and I use the events. In this category, I was using event over here. You can see events. You can see buffer memory, make, system, radio. As per the, you can use the parameter also. And you can see all the boot applications are running over there. Pre-default start, preload, system run, start, PMS system and scan start. All the things are given one by one. So the most important part is to analyze how the mobile architecture works in the backend process, so we can go for further steps. Or you can look for the preloads. I'm gonna look for preloads. Bootloader and preloads are totally different. So let's try the preload part. So I'm going to use adb.cat and I'm going to use grep command over here, preload. So through the preload function, I can see one by one, but it's going to catch all the application which is from Zygote, which is running as a lower processors. So we can see the process ID numbers one by one. So the most important part is to understand how the mobile application architecture works, because these are the services which is running. And we have to memory dump which application is running in the processing memory over there. System services, we can see Zygote plays a major role because it contains some socket connections, some classes, some resources, everything that is included in the Android are be loaded with the method, themes and layout. It's all about the boot memory which the Zygote uses in the Delvic part. So over here, the most important part is the entire sequence part of this Android process runtime, which has the 6th layer, which is your boot ROM, your bootloader, your kernel, your initialization, which is the important part. Each and every time when the application will run, the first memory will be consumed by the initialization part. Then your Zygote is basically used for your low memory consumption part in your Delvic machines, service managers, system services, which are the application which is running in the backend, and managers, which contains all the log activities of the services. Each and every service has a manager to understand how the runtime works in the real life upcoming chassis. So the most important part is to understand how the mobile applications works